In 1968, the commander of Apollo 8, Frank Borman, looked out his window at a world that seemed completely exhausted. He saw a surface scarred by meteorite craters and volcanic residue. To Borman, the moon was a monochromatic wasteland. There was no color here, just varying shades of gray, black, and white. But as the spacecraft completed its fourth orbit, a sharp contrast appeared. A brilliant blue sphere began to rise over the lunar horizon. Astronaut Bill Anders scrambled to capture the moment. At the time, NASA hadn't even considered the shot. Their flight plan was entirely focused on the lunar surface, not looking back. This image was reproduced billions of times, showing the Earth as a lonely, colorful island in a vast vacuum. By 1970, that sense of shared isolation provided the emotional foundation for the very first Earth Day. Now, 58 years later, the Artemis II crew has intentionally recreated that precise moment. They called the new image Earthset. While the framing of the two photos is identical, the world inside the frame has changed during the few decades between them. Environmental damage existed in 1968, but it was often a local experience. You could see it in the thick smog over Los Angeles or hear about rivers that had caught fire. Over the next 60 years, those localized issues evolved into a structural shift that altered the planet on a global scale. This chart shows the hidden data. Since 1968, atmospheric CO2 has risen by 1/3, and global temperatures climbed a full degree Celsius. This correlates with visible land changes. From orbit, we see dark forests cleared for bright grids of industrial agriculture. Perhaps the most striking evidence is the Aral Sea. Once a massive body of water, it has desiccated to less than 10% of its 1960 size, leaving a graveyard of ships in the sand. These changes demonstrate that the Earth is no longer just a backdrop, but a single biological system reacting to human activity. We see these reactions clearly in the Cryosphere, where warming waters cause massive sheets of glacial ice to break apart and drop into the ocean. The scale of this loss is hard to fathom. In the time between these two lunar missions, 28,000 kilometers of Antarctic ice shelf have collapsed. Today, a vast network of robotic satellites monitors this decay every hour, tracking the planet in everything from microwaves to ultraviolet light. But if we already have thousands of machines providing perfect data, why do we still need a human to take a photo from the moon? Experts suggest that while satellites provide numbers, humans provide perspective. An astronaut makes subconscious choices about framing that force us to look at the Earth as a home rather than a data point. Cold data rarely moves a society to change. It is the emotional weight of seeing our home through human eyes that bridges the gap between knowing the facts and feeling their impact. When we look at the 2026 Earthset image, we encounter a paradox. From 240,000 miles away, the Earth still looks like a perfect glowing marble. The macro beauty of the blue oceans and white clouds hides the reality of the retreating ice and shrinking seas happening just beneath them. The 1968 image worked because it shifted our perspective, showing us for the first time that we were all on the same small boat. The 2026 image serves as a progress report. It is a reminder that the perfect world we see from a distance is being reshaped by our own hands. We are still that same blue sphere suspended in the dark. Frank Borman's realization remains the core of the mission. We traveled all the way to the moon to explore the void, only to find that the most important thing to look at was ourselves.